Good day, everyone. I am Jonomi Amoryuki, and we are the Group 9 reporters. We're tasked to discuss the Chapter 9, which is the statics and torque. For this topic, it composed of 6 chapter outlines. First, the first condition for equilibrium. Second, the second condition for equilibrium. Next, the stability, applications of statics including problem-solving strategies, and then the simple machines, and the last one, forces and torques in muscles and joints. So, give me a simple introduction for this topic. Newton's second law states that net force is equals to mass times acceleration. And so, the net external force is zero for all stationary objects and for all objects moving at constant velocity. There are forces acting, but they are in balance. So, that is called the equilibrium. So for now, before I go on with the topic that I have assigned, let me define what is statics. Statics is the study of forces in equilibrium, a large group of situations that makes up a special case of Newton's second law. So now, the first topic that I'm going to discuss is the first condition for equilibrium. I know it is unfamiliar to us. So in this topic, it composed of 3 chapter objectives. First, state the first condition of equilibrium, then explain static equilibrium, and the last one, explain dynamic equilibrium. The first condition to achieve equilibrium is that the net external force on the system must be zero. So, express in the equation this one. Remember that for an object to be in equilibrium, it must be experiencing no acceleration. This means that both the net force and the net torque of the object must be zero. Then the external force in any direction is zero. For example, the net external forces along the typical x and y axis are zero. That's one. So, for example, in figure 9.2, it shows the motionless person. The motionless person is in static equilibrium since the forces acting on him add up to zero. So the both forces are vertical in this case, while in 9.3, it shows the dynamic equilibrium. Since the car is moving at constant velocity, and there are horizontal and vertical forces, but the net external force in any direction is zero. Then the applied force between the tires and the road is balanced by air friction, and the weight of the car is supported by normal forces, here shown to be equal for all 4 tires. So next, however, it is not sufficient for the net external force of a system to be zero for a system in equilibrium. The point at which a force is applied is another factor in determining whether or not equilibrium is achieved. So in the first figure, it shows that equilibrium remains stationary since walay changes iyahang position. Now, thus force is equals to zero. And then equilibrium is achieved, which is in static equilibrium. Static equilibrium ning first figure. While in the second, it is non-equilibrium since rotation accelerates. na siya changes. The same forces are applied at other points and the stick rotates. In fact, it experiences an accelerated rotation. Here, net force is equals to 0, but the system is not at equilibrium. Hence, the net force is equals to 0 is a necessary but not sufficient condition for achieving the equilibrium. Muna'y kalahian sa duha.